Okay, so here comes to the property of determinants. Now, after they investigate, the original purpose is to find solution of a system of equation. And after that, they know how to expand or define what we said, just mentioned, a determinant. Right? They study the property of determinant and find a lot of fruitful properties there or outcomes. Right? And let's take a look at what these are. Now, the first property is about. Now, you can see that these two, according to the arrangement of all the 9 elements inside this 3x3 determinant, right? These are all different, right? Except the column. Can you see that the original position of A, E, I carries the same? However, there are changes on other elements, D, G, H. Just like an image, flip to the other side, right? And then E, C, F, flip the other side. But of course, you can look at the whole thing as an image, right? Reflection along the diagonal. But it could also be interpreted as the interchange of all rows and columns. So originally, the first row is IDG, and it comes to IDG as the row, right? Originally, column, the first column changed to the first row. The second column, BEH, changed to the second row. And third column, CFI, changed to the third row. Right? So that was the way that we tell about the change or rearrangement of these determinant elements. And they are the same. They are the same. Rearranging or interchanging the row and column of the determinant will not affect the value. That was what this property tells. Do you know why? Do you know why? Okay, so save your time. Actually, this is fruitful for investigation. So, but since I prepared PowerPoint, so I showed you, right? Maybe if you look at the video, you can take time, pause a while, do some investigation before you move on to the next. Now, here is our explanation. Now, it's easy because the expansion, according to the second rule, apart from the rule of Cyrus, the second rule, right? We can expand in this one. I use A, B, C, a third row in our expansion, right? So here are our expansion. Agree? First of all, agree. Right? Before, be mindful of the negative sign, of course, right? Always refer to the sign first before you come over to the expansion. Okay? So if that's the case, look at the right-hand side. Right? Because the rule will not be affected by the choice of our row or column in our expansion. So this time I can choose the first column. Right? Instead of the first row, I choose the first column. Right? Can you see that? If I choose the first column, so here is our expansion. Right? Oh, and please compare with these two. Okay? Are they the same? Are they the same? Are they the same? Right? Although some of the arrangement of the elements are different, but they carry the same value after expanding. These two, are they the same? It's just about interchange of the column, right? The G and F, but actually they are the same. So look at these two again. Same, right? So we can tell these two, left-hand side, right-hand side, are the same. So interchanging all the rows and columns accordingly. Don't interchange the second row to the third column, right? We're changing the first row to the first column. Second row, second column. Third row, third column, right? If you change accordingly, the value will restore, will remain unchanged. Okay? That's the first property. Okay? Right, the second property. Now, the second property tells you that there are changes in elements. Can you see that? What is the change now? You can see from this diagram. The figure. I gave these two expressions on the left-hand side and right-hand side. What are the changes? Don't look at the heading. Just look at the two determinants. Can you see any changes on that? I think third row with columns remain the same, right? It's just an interchange between the first and the second column, right? And if that's the case, the value will change to negative. Change to negative, right? And that's why in order to compensate that effect, I have to put a negative sign in order to make them equal. Clear? Did you know why? Did you know why? You can get hints from the sign. Do you remember the sign? Right? This is positive, negative, positive according to the expansion, right? And this becomes what? Negative, negative, positive, negative, right? Okay? Right? So according to the expansion, if I choose column CFI as the way that we expand, then the whole thing will reverse. I mean, the sign will reverse. Agree? Okay. We'll capture that part. Don't worry. Okay. So the explanation is that now if you change this, now you choose again this row, expanded form, right? Okay, we've got this. And then on the right hand side, you choose expansion along the first row again, So B, A, and C, right? Okay. Of course, since we have left hand side that there is a negative on the the right hand side, we have to put this right hand side here. Right? See that? Okay. So D, F, G, I, E, F, H, I, and then E, D, H, G. Right? Fine. Okay. And afterward, you know that this could be changed because if G, H, D, H, G, D, H, G interchange, right? Can you see that again? They change, right? Okay, and since the change swap the order of the expansion along to the roots, it will be a negative sign coming out. Okay, and you can see that all these carries. Okay, negative B with this same, and then this one negative A. Right, but since multiplying negative, so that was positive, and finally this one is positive. So we can cross check with all these. Okay. No, not limited to row, but if you let's say change the not column. The original one that I gave you here is interchanging the first and the second column. But what happened if I change the row? Right, the second row and the third row. Will it be the same? You can expand and then compare again. Okay. And finally, you got the same answer. Right, swap a bit, and then the answer is the same. Okay. So remember, the second property is that when you interchange only among the two column or any two rows within the determinant, right, the value will change from positive to negative or from negative to positive. Okay? Okay? So what you need to do is to make a negative sign out in order to compensate, make them equal. Okay? Now this is the one that carried from the previous example 5. Can you see that? Right, it's either the row along the row or along the column. In this example, is along the first row. We have common factor k, right? Okay, so can we take this k as a common factor? This would be yes, because according to the expansion and the right hand side. Okay, you can see that that is obvious, right? Because we take the first row as an expansion, and all the elements in the first row is having k as a common factor. And that's why in the expansion, that k should be automatically taken out, could be automatically taken out. And that was the factors of the whole determinant. Okay? Is that clear? Okay, of course, along the column, we can do the same thing, because we can expand through along the column that involve the factor k. Okay, and that will not affect the value after taking the k's out. Clear? Clear? Okay? So that is the third property. The fourth property is so obvious and trivial. Can you see that? If any row or any columns having all 0, right? Having all elements 0 in any one column or any row, the value is 0. Do I need to prove? Do I need to prove? No, right? Okay, so it's all obvious. You just choose that column or row, and you got 0, definitely. Okay? Now comes to the fifth one, right? Okay, so you can see that now this time, can you see any specific property about this determinant? And why this is 0? Look at that, please. What you can see is that the second row, please focus on the second row and the third row. Now it could be applied to other column as well, right? It could be the first column. It could be the third column. Please follow the rules. You can always interchange column, right, with some compensation. Now, in my example, I choose the second row and the third row. And you can see some relationship among them. And what are they? The relationship. What can you see from the second row and the third row? What can you see? This is DEF, right? And this is KD, KE, KF, right? We call this proportional. Can you see that? The corresponding element proportional. Just like similar, the length, all the three sides of a similar figure, right? They are proportional. Okay? So once you find that some of the row corresponding elements of the rows are in proportion, you can tell the answer of the expanded form to be 0, strictly 0, right away. Right? Why? It's easy. Since they are proportional, there's a governing factor k, right? And that was indicated in my notes. Right? K. That k, can k be taken away? Can k be taken away? Right? And after k taken away, of course you can take away k first. And you can see that those cofactors are all the same. Right? If you expand along the first row, all the remaining are the same. Right? So it's EF, EF, DF, DF, DE, DE. And definitely this will be 0, right? Since they are proportional. After taking out k, they are all 0. Even that happens in the column. We choose our expanded form in the third one. I choose ADE as an expanded form, right, to be expanded. And then remaining all 0 cofactor, right? Okay, and that will definitely be 0. Now, this is the sixth property. Now, the sixth property tells you something about breaking down of determinant. Now, sorry to tell you that you have to put everything all at a sudden, like all at a sudden in your mind. But actually, I tell you, the best way to remember all these properties is to work on the exercise in the textbook. Right? The more you work on, the more firm the property carries in your mind. Right? So if all the elements in any row or column are expressed as the sum of two terms, right, then the determinant can also be expressed as the sum of the determinant. I don't think that was difficult. Agree? Let's take the extended form along this the first column. Right? And then can this be rearranged? This way? And this way. It's easy, right? It's easy, right? Okay, because it expands, and after that, that was distributive law. This have to be a multiply A and at the same time multiply B. And the sign carry, am I right? And then similarly for this one, right? The sign still carry negative. And this one, G and R, the sign still carry. Right? Okay, and that was our right hand side. Right? Right, let's split up into two. The sum of two. Okay, as long as we know. Okay? So somehow it could help to reduce the size of it. Because we know that as long as we have something in proportional, especially you know the previous property, right? It will make 1 times 0 then. Do you understand? That will make easier expansion afterward. If you have large values, especially when you have large values in the determinant, this is a good method helping you to reduce the size or values of these elements inside the determinant. Okay? We will know how to do it later on. And this is the property carried from 6 because you see that this is why I say you can reduce. Right? As long as we can find this, and we know that they can. So, and remember, you can see that pay attention to the second term of each elements here in the first column. This is KB, this is KE, this is KH, which is actually proportional to the second column, right? And that's why the expanded form, remember previously we have the second part, right? Right? And in this case, if we have the expanded part, then that part will be 0, right? Because they are proportional. Right? And that's why I tell you can reduce this great number to a small number a in this case. Do you agree? Right? Try to make things here proportional and then you can have your better result. Right? A simpler result with smaller value so as to make an expansion easy afterwards.